Good morning, everyone. I'm Alina, Program Manager for TensorFlow. Thank you. Welcome to the 2019 TensorFlow Developer Summit. This is our third annual and largest developer summit to date, and I'm so happy to have all of you here, both right here in the room and on the live stream. Welcome. So I'm just curious, by a show of hands, who traveled a little bit further maybe to get here? Europe? Asia? Africa? As far as Australia? Woo! Awesome. Welcome to all of you. We have a lot of great talks ahead, some exciting announcements and cool demos, so let's get going. We are living in a formative moment of history right now, where machine learning is experiencing an unprecedented revolution that we fundamentally think about and interact with computer systems has inherently changed due to the breakthroughs in the field of AI. And this is due to three major factors. First, we have lots more compute, specially designed ML accelerators like these TPUs let you train models faster than ever before. Secondly, we have breakthroughs in the field of machine learning. There are novel algorithms created every month, like BERT, and an innovative approach to natural language processing, which lets anyone around the world train their own state-of-the-art question answering system. And finally, we have lots and lots of data. We're seeing new waves of data sets come from all kinds of disciplines. For example, the new Open Images Extended dataset. This is a collection of over 478,000 images that volunteers have added with the pursuit of inclusivity and diversity. So all three of these are basically changing how we solve challenging real-world problems. And it's really cool to see that TensorFlow is the platform that's powering this machine learning revolution. It's allowing developers, businesses, and researchers around the world to benefit from intelligent applications. And we've been really amazed by what the community has built with TensorFlow. Developers have been using TensorFlow to solve problems in their local communities. So I don't know if any of you were in the Bay Area during the tragic Paradise Fire, but one of the consequences was that air quality was really bad. It was in the high to mid 200s on the air quality index. And as difficult as this was for us, in Delhi, India, during winter, the air quality can get up to about the 400s on the air quality index. And this is considered very dangerous. So pollution sensors can help gauge air quality, but they're very expensive to deploy at scale. So a group of students in Delhi built image classifiers in TensorFlow and used those to then build an app called Air Cognizer. And what it does is basically just by using the images on a smartphone, it gives an accurate estimation of the air quality. Businesses are also fundamentally improving their products and services built with TensorFlow. For example, Twitter strives to keep its global users informed with relevant and healthy content. But this can be hard when users follow hundreds or even thousands of people. So to solve this, Twitter launched Ranked Timeline, an ML-powered feed which shows the most relevant tweets at the top of the timeline, ensuring users never miss their best and most relevant content. And by using TensorFlow's ecosystem of tools like TensorFlow Hub, TensorBoard, and TensorFlow Model Analysis, Twitter was able to reduce both training and model iteration time, as well as increase the timeline quality and engagement for users. Specific industries are also being very much transformed by ML. GE Healthcare, for example, is using TensorFlow to improve MRI imaging. They use TensorFlow models that run real time on MRI scanners and can actually detect the orientation of the patient inside the scanner. And this is really great because not only does this help the diagnosis, but also lowers the errors and exam time. But also what's really cool is it basically expands this technology to many, many more people around the world. TensorFlow also powers bleeding-edge research. A team of scientists, researchers, and engineers at NERSC, Oak Ridge National Laboratory, and NVIDIA recently won the Gordon Bell Prize for applying deep learning to study the effects of extreme weather patterns using high-performance computing. They built and scaled a neural network to using TensorFlow, of course, to run on Summit, the world's fastest supercomputer. They achieved a peak and sustained throughput of 1.13 exaflops in FP16, which is equivalent to more than a quintillion computations per second. I just think I need to pause for a second because that is ridiculously fast, right? In addition to these awesome examples, there are thousands and thousands of people all over the world doing amazing work using TensorFlow. And the power and impact of TensorFlow would not be what it is without all of you. Thank you. It's with your help and interest that TensorFlow has become the most widely adopted ML framework in the world. And right here, I'd like to show the latest map of GitHub stars who self-identified their location. I'm sure many of the dots on this map are right here in the room and on the live stream, so I just want to say thank you one more time. And this growth has been absolutely amazing. TensorFlow has been downloaded over 41 million times and has over 1,800 contributors worldwide. Last November, we celebrated TensorFlow's third birthday by taking a look back at the different components that we've added throughout the years. But today, we'd like to talk about how TensorFlow has matured as a platform to become an entire end-to-end ecosystem. And TensorFlow 2.0 is the start of a new era, and we're committed and focused on making it the best ML platform for all users. To talk more about TensorFlow 2.0, I'd like to introduce Rajat Manga, Engineering Director of TensorFlow, on stage. Thank you.
Thank you, Alina. Hello, everyone. I'm Rajat. I'm an engineer on TensorFlow and have been involved with this since the very beginning. And it's been great to see what we've been up to over the last few years, all the amazing growth and all the amazing things that you've done with it. It's also been great to hear from you. You told us what you like about TensorFlow, and equally importantly, what you would like to see improved in TensorFlow. Your feedback's been loud and clear. You asked for simpler, more intuitive APIs and development experiences. You pointed out areas of redundancy and complexity. And you asked for better documentation and examples. And this is exactly what we've been focusing on with TensorFlow 2.0. To make it easy, we focused on Keras for a single set of APIs and combine it with eager execution for the simplicity of Python. With flexibility to try the craziest ideas and ability to go beyond an exaflop, TensorFlow is more powerful than ever. With the same robustness and performance you expect in production battle-tested at Google. Let's start with the overall architecture for TensorFlow. You may be familiar with this high-level architecture. There have been lots of components and features we've added throughout the years to help support workloads to go from training to deployment. With TensorFlow 2.0, we're really making sure that these components work better together. Here's how these powerful API components fit together for the entire training workflow. With TF data for data ingestion and transformation, Keras and pre-made estimators for model building, training with eager execution and graphs, and finally packaging for deployment with Save Model. Let's take a look at some examples. The first thing you need is data. Often you may want to validate results or test your new ideas on a common public data set. TensorFlow datasets includes a large and rapidly growing collection of public datasets that you can get started with very easily. And combined with TF data, it is simple to wrap your own data to. Here's a small sample of the datasets that are available, and all of these and many more are included there. Then with Keras, you can express the model with layers just as you are used to thinking about it. Standard training and evaluation is packaged as well with model fit and evaluate. Since deep learning models are often computationally expensive, you may want to try scaling this across more than one device. TensorFlow comes pre-built with mirrored strategy that works with small additions to your code. Starting from a pre-trained model or component also works well to reduce some of this computational cost. To make it easy, TensorFlow Hub provides a large collection of pre-trained components that you can include in your model and even fine-tune for your specific dataset. Keras and Estimator offer high-level building blocks for an easy-to-use package. They come with everything you might need for typical training jobs. But sometimes you need a bit more control. For example, when you're exploring new kinds of algorithms. Let's say you wanted to build a custom encoder for machine translation. Here's how you might do this by subclassing a model. Here you can focus on implementing the computational algorithm and let the framework take care of the rest. And you could even customize the training loop to get full control over the gradients and the optimization process. While training models, whether packaged with Keras or more complex ones, it's often valuable to understand the progress and even analyze the model in detail. TensorBoard provides a lot of visualization to help with this. And now it comes full integration into Colab and other Jupyter notebooks, allowing you to see the same visualizations right from within your notebook. All of these features are available in TensorFlow 2.0. And I'm really excited to announce that our alpha release is available for you as of today. Many of you in the room and across the world really helped with lots of work and testing to make this possible. I'd really like to take this moment to thank you all. Please give yourself a round of applause. We really couldn't have done this without you. In addition to all the great improvements we talked about, this release comes with a converter script to help you upgrade from 1.x and a compatibility module to give you access to the 1.x APIs for easy transition. And we are working towards a full release over the next quarter. There's a lot of work going on to make TensorFlow 2.0 really work well for you. You can track the progress and provide feedback on the TensorFlow GitHub projects page. You asked for better documentation, and we've worked to streamline our docs for APIs, guides, and tutorials. All of this material will be available today on the newly redesigned TensorFlow.org website, where you'll find more examples, documentation, and tools to get started. We're really very excited about these changes and what's to come. And to tell you more about improvements in TensorFlow for research and production, I'd like to welcome Megan Caccioli on stage. Thank you.
Thanks, Rajat. TensorFlow has always been a platform for research to production. We just saw how TensorFlow's high-level APIs make it easy to get started and build your models. Now let's talk about how it improves powerful experimentation for researchers and lets you take models from research and prototyping all the way through to production. Researchers have been using TensorFlow for state-of-the-art research. We can see it in paper publications, which are shown over the past few years in this chart. But powerful experimentation begins and really needs flexibility. This begins with eager execution with TensorFlow. In TensorFlow 2.0, by default, every Python command is immediately executed. This means you can write your code in the style you're used to without having to use session run. This also makes a big difference in the realm of debugging. As you iterate through with eager mode, you'll eventually want to distribute your code onto GPUs, TPUs, and other hardware or accelerators. For this, we've provided TF function, which turns your eager code into a graph, function by function. You get all of the familiar tools like Python control flow, asserts, even print, but can convert to a graph anytime you need to, including when you're ready to move your model into production. And even with this, you'll continue to get great debugging. Debuggability is great not just in eager, but we've made huge improvements in TF function and graphs as well. In this example shown here, we're splitting a tensor using TF function, which creates a graph. But because of the mismatched inputs, you get an error. As you can see, we now give users the information about the file and the line number where the error occurred in the model to help you more quickly track things down so you can continue iterating. We've made the error messages concise, easy to understand, and actionable. We hope you enjoy these changes and they make it much easier for you to quickly iterate and progress with your models. Performance is another area we know that researchers, as well as all users for that matter, care about, and we've continued improving core performance in TensorFlow. Since last year, we've sped up training on 8 NVIDIA Tesla V100s by almost double. Using a Google Cloud TPU v2, we've boosted performance by 1.6x. And with Intel MKL acceleration, we've gotten inference speed up by almost 3 times. Performance will continue to be a big focus of TensorFlow 2.0 and a core part of our progress to final release. TensorFlow also provides flexibility to enable researchers, and this is with many add-on libraries that extend and expand TensorFlow in new and useful ways. Some of these add-on libraries are extensions to make certain problems easier, like tf.text with Unicode and the new ragged tensor type. In other cases, it lets us explore how we can make machine learning models fairer and safer via TF privacy. You'll also hear new announcements on TF agents for reinforcement learning, and tomorrow we'll be discussing the new TF federated library for federated learning. Deep learning research is also being applied to real-world applications using TensorFlow. Here are a few examples from researchers at Google where we see them applying it to areas like our data centers, where we're making them more efficient with AI control system that delivers energy savings. Our apps, like Google Maps, the one shown in the middle, which has a new navigation feature called global localization. It combines visual positioning service, street view, and machine learning to more accurately identify position and orientation. And devices like the Google Pixel that use machine learning to improve depth estimation to create better portrait mode photos, like the one shown here. In order to make these real-world applications a reality, you must be able to take models from research and prototyping all the way through to launching in production. This has always been a core strength and focus for TensorFlow. Using TensorFlow, you can deploy your models on a number of platforms, like shown here. And models end up in a lot of places, so we want to make sure TensorFlow works well across all of these, on servers and in cloud, on mobile and other edge devices, in browser and JavaScript platforms. We have products for each of these: TensorFlow Extended, TensorFlow Lite, and TensorFlow.js, which I'll briefly talk through. TensorFlow Extended is our end-to-end platform for managing every stage of the machine learning lifecycle. This spans all the way from ingesting and transforming your data to deploying your machine learning models at scale. In orange, shown here, you can see the libraries we've open sourced so far. What this slide alludes to is that we're now taking a step further and providing components built from these libraries that make up an end-to-end platform. And note, these are the same components that are used internally in thousands of production systems powering Google's most important products. But components are only part of the story. 2019 is the year we're putting it all together and providing you with an integrated end-to-end platform. First, you can bring your own orchestrator. Here, we're showing Airflow or Kubeflow or even raw Kubernetes, whatever you want. No matter what orchestrator you choose, the TensorFlow Extended components integrate with a metadata store. This store keeps track of all the component runs, the artifacts that went into them, and the artifacts that were also produced. This enables advanced features like experimentation and experiment tracking, model comparison, and things along those lines that I'm sure you'll be excited about and will help you as you iterate through and work with your production systems. We have an end-to-end talk coming up later today from Clemens and his team, in which they'll take you on a complete tour of using TensorFlow Extended to solve a real problem. Moving on, TensorFlow Lite is our solution for running models on mobile and IoT hardware. It uses a custom streamlined file format and a stripped-down runtime, so you can deploy TensorFlow models everywhere your users are. On-device models can be more responsive to input than cloud backends, and they keep user data on-device for privacy, which is very important, especially in this day and age. Google and our partners like iQIYI in China use TF Lite for all kinds of tools, including predictive text generation, video segmentation, and things like edge detection. But under the hood, TensorFlow Lite is about performance. You can deploy models to CPU, GPU, and even edge TPUs and expect fast performance. And we've been refining since we launched TensorFlow Lite last year. By using the latest quantization techniques on CPU, adding support for OpenGL 3.1 and Metal on GPUs, and tuning our performance on edge TPUs, we're constantly pushing the limits of what is possible on device. And you should expect even greater enhancements in the year ahead. We'll hear details from Raziel and his colleagues coming up in a little bit this morning. JavaScript is the #1 programming language in the world, and until recently hasn't necessarily benefited from all the machine learning development and tools. Last year, we released TensorFlow.js, a library for training and deploying machine learning models in the browser and on Node.js. Since then, we've seen huge adoption in the JavaScript community with more than 300,000 downloads and 100 contributors. But we're just at the beginning given how big the JavaScript and web ecosystem is. Today, we're excited to announce TensorFlow.js version 1.0. This comes with many improvements and new features. We have a library of off-the-shelf models for common machine learning problems that run both in the browser and on Node. We're also adding support for more platforms where JavaScript runs, such as Electron desktop apps or mobile native platforms. And a huge focus in TensorFlow.js 1.0 is on performance improvements. As an example, compared to last year, mobile net inference in browser is now 9 times faster. You'll learn more about these advances in our talk later in the day. Another language that we're really excited about is Swift. Swift for TensorFlow is re-examining what it means for performance and usability, with a new stack built on top of TensorFlow's core and a new programming model that intends to bring further usability. And today we're announcing that Swift for TensorFlow is now at version 0.2. It's ready for you to experiment with, to try out, and we're really excited to be bringing this to the community. In addition to telling you about version 0.2, we're also excited to announce that Jeremy Howard of Fast.ai is writing a new course in Swift for TensorFlow. Chris and Brennan will tell you a lot more about this later today. So to recap everything we've shown you so far, TensorFlow has grown to a full ecosystem, from research to production, from server to mobile, with many languages. This growth has been fueled by our community and honestly would not have been possible without the community. To talk about what we're planning for you and with you in 2019, I'll hand it over to Kamal. It's all you.
Thank you, Megan. Hi, my name is Kamal, and I'm the product director for TensorFlow. I'm really excited to be here today for this celebration. And what we're celebrating is the most important part of what we're building, and that's the community. Personally, I love building developer platforms. I used to be a developer as an entrepreneur, and now I get to enable other developers by building together a better platform. When we started working on 2.0, we turned to the community. We started with the request for common process, consulting with all of you on important product decisions. We received valuable feedback, and we couldn't have built 2.0 without you. And some of you wanted to get more involved, so we created special interest groups, or SIGs, like networking or TensorBoard, to name a few. And SIGs are really a great way for the community to build the pieces of TensorFlow that they care the most about. We also wanted to hear more about what you were building, so we launched the Powered by TensorFlow campaign. And I gotta say, we were amazed by the creativity of the project, from biological image analysis to custom wearables to chatbots. So after 3 years, our community is really thriving. There are almost 70 machine learning GDEs right now around the world, 1,800 contributors on core alone, and countless more of you who are doing amazing work to help make TensorFlow successful. So on behalf of the whole TensorFlow team, we want to say a huge thank you. So we have big plans for 2019. And I would like to make a few announcements. First, as our community grows, we welcome people who are new to machine learning. And it's really important to provide them with the best educational material. So we're excited to announce 2 new online courses. One is with deeplearning.ai, and it's published on the Coursera platform, and the other is with Udacity. The first batch of these lessons is available right now, and they provide an awesome introduction to TensorFlow for developers. They require no prior knowledge to machine learning, so I highly encourage you to check them out. Next, if you're a student, for the very first time, you can apply to the Google Summer of Code program and get to work with the TensorFlow engineering team to help build a part of TensorFlow. I also talked about the Powered by TensorFlow campaign. We're so excited with the creativity that we decided to launch a 2.0 hackathon on DevPost to let you share your latest and greatest and win cool prizes. So we're really excited to see what you're going to build. Finally, as our ecosystem grows, we're now having a second day at the summit, but we really wanted to do something more. we wanted a place where you can share what you've been building on TensorFlow. So we're excited to announce TensorFlow World, a week-long conference dedicated to open source collaboration. This conference will be co-presented by O'Reilly Media and TensorFlow, and will be held in Santa Clara end of October. Our vision is to bring together the awesome TensorFlow world and give a place for folks to connect with each other. So I'd like to invite on stage Gina Blaber to say a few words about the conference.
Thank you, Kamal. O'Reilly is a learning company with a focus on technology and business. We have strong ties with the open source community, as many of you know, and we have a history of bringing big ideas to life. That's why we're excited about partnering with TensorFlow to create this new event that brings machine learning and AI to the community. The event is TensorFlow, happening October 28 to 31 in Santa Clara. And when I say community, I mean everyone. We want to bring together the entire TensorFlow community of individuals and teams and enterprises. This is the place where you'll meet experts from around the world, the team that actually creates TensorFlow, and the companies and enterprises that will help you deploy it. We have an open CFP right now on the TensorFlow World site. I invite you all to check that out and send in your proposals soon so your voice is heard at that event. We look forward to seeing you at TensorFlow World in October. Thank you.
Thank you, Gina. This is going to be great. Are you guys excited? Woo! So we have a few calls to action for you. Take a course, submit a talk to TF World, start hacking in 2.0. By the way, the grand prizes for a hackathon on DevPost will include free tickets to TensorFlow World. You know, one thing I love is to hear about these amazing stories of people building awesome stuff on top of TensorFlow. And as a team, we really believe that AI advances faster when people have access to our tools and can then apply
exact technique. So that's about it for the demo. But before I go, I should grab the clicker, and also I should say, we're also giving away some Edge TPU accelerators. For those of you here today, we'll have one available for you as well. And for those of you on the live stream, you can purchase one at coral.withgoogle.com. Okay. So we've also got some links for you up here. Please take a look at the TensorFlow Lite and our new hardware. And thank you very much.
Hi, everyone. My name is Gal Oshri, and I'm here to talk to you about TensorBoard and what's new in TensorFlow's visualization toolkit. So how many of you have used TensorBoard before? Awesome. So as you know, TensorBoard helps you visualize a lot of the data that comes out of TensorFlow. It has a wide variety of features, but today we're going to talk about a couple of new additions. So we're actually going to switch over to a demo. So this is Colab, a service from Google Research that makes it really easy to get started with TensorFlow. If you've seen the TensorFlow documentation, you've probably used Colab. A few minutes before the demo, I made sure that we have installed TensorFlow 2.0 Alpha and a couple of other setup steps so we don't have to do them right now. We're going to use the Fashion MNIST dataset, one that I'm sure you've never seen before. And we're going to train a really simple Keras sequential model, one that just has a few layers, including dense and dropout layers. We're going to train it with the fit API and give it the TensorBoard callback so that we make sure that we log the right data to visualize in TensorBoard. Now, if you've used Colab before, you'll know that at this stage, we would need to download the logs to our local machine, make sure TensorBoard is set up, point it at those logs, and then look at them, and then go back to Colab again. That's not very convenient. So what we've done is enabled showing TensorBoard directly within Colab. You'll notice that the way that we start TensorBoard here is exactly the same as in the command line. It's the same command, just has the magic cell and magic function in front of it. The same thing would also work in Jupyter Notebooks. So let's see what's different. Well, first of all, when using the Keras callback, we now have train and validation showing up on the same charts to make it much easier to compare them in accuracy, loss, and other metrics. This makes it easier to detect things like overfitting. In the graphs dashboard, while seeing all of the ops and auxiliary information is useful for many scenarios, sometimes you just want to see what is the model that I created in Keras? What are the layers in it? So you can now switch to the Keras tag and just view that model. We can expand this to see the actual layers that we added. There are several other APIs for using TensorBoard within notebooks that let you change the height of the cell, as well as list the active instances within your Colab notebook. But we're not going to look at that today, because I want to switch gears and talk about hyperparameter tuning. Now, the model that we created was extremely simple, and we picked a couple of hyperparameters for it: the dropout rate, the number of units in the dense layer, and the optimizer. Now, if we really cared about that model's performance, we're going to want to try out different values. We're going to want to experiment with several of them and see which one leads to the best model. The way this would look today in TensorBoard
We're doing a contributor luncheon tomorrow, where there'll be a little panel discussion about contributing to TensorFlow, and many of the core team and the SIG leaders will be there to talk to you. So, finally, let's move on and talk about TensorFlow World. I'm so excited about this. It's our vision to bring together the amazing people who are part of our community and give us space for everyone to connect with each other. You know, there's so much we can all learn from how we're all working with TensorFlow. So working with O'Reilly Media, we're going to have this event at the end of October this year here in Santa Clara. It'll be 4 days that really celebrate the TensorFlow ecosystem. We'll have content from talks to tutorials. There'll be an expo and a place for vendors to present. So we understand as TensorFlow gets out into the real world, there is a large ecosystem beyond folks in this room. And we're really excited that that means that we can bring everyone together. You know, the main point of doing something like this is to connect all the amazing users and everyone with experience to share. As you heard, the call for proposals is now open. So if you have anything to share with your work, your product, your company, head to TensorFlow World, put in a proposal. You've got about 4 or 5 weeks while the call for proposals is open, and then we'll be selecting talks a few weeks after that. I really hope that you will lend your voice to this event, and I'm so excited to see you all in October. So once again, thank you. We really appreciate how much that you are part of our community. Honestly, in my job, the best thing every day is when I get to talk to folks who are using or developing TensorFlow, and I know that's the same for everyone in the team. It really is so exciting to work with everybody here. This is the way you can meet me. Please do, if you have any issue or any desire to contribute or get involved with the community, reach out. We're really happy to talk to you. So thank you very much for your attention.
extreme weather is changing. There's more extreme rainfall, heavy flooding, forest fires. There isn't really a signature down. Being able to predict these extreme events more accurately is kind of the big challenge that we're facing right now. There's 100 terabytes of climate data every day from satellites, from observations, from models. So climate data is a big data problem. We need things that are fast, that can sift through all of that data rapidly and accurately. And deep learning is almost perfectly poised for problems in climate science.
A lot of NERSC users are using TensorFlow. It's one of the more popular frameworks. We use TensorFlow to iterate quickly over different models, different layer parameters. For this particular climate project, to create the deep learning model, we started from segmentation models which have proven to be successful, for example, our satellite imagery segmentation tasks. And then we used TensorFlow to enhance the models until we found like a set of models which perform well enough for this specific task. But for the volume of the data, complexity of the data, the network required 14 teraflops. So if you want to do this on your workstation, it would take like months to train.
To really tackle these problems requires the largest computational resources that are available on the planet. So systems like the Summit supercomputer. It's 2 tennis courts in total size. I mean, this thing is state-of-the-art. It's 1,000,000 times faster than your common laptop. 3.3 exaflops. Just imagine what you do at your workstation, but now imagine having 27,000 times that power. We can do that now.
We were surprised how good it actually scales. 1,000 nodes and 2,000 nodes, 5,000 nodes.
This was the first time anybody's ever run an AI application at this scale. Instead of having the climate scientists figure out how to write high-tune code, they could express things in a very natural way in Python in TensorFlow and get all the high-performance code that most HPC people are used to within TensorFlow.
We're now entering the space where AI can actually contribute to the predictions of these extreme weather events.
When you combine traditional HPC with AI, you can tackle things we never thought that we could tackle. Fusion reactor research, understanding diseases like Alzheimer's, cancer, right? That's incredible.
We've shown that with a high productivity framework such as TensorFlow, you can get to massive scale and you can get awesome performance and accomplish your goals.
Genetics, neuroscience, cosmology, high energy physics. That's immensely exciting for me.
Okay, hello everyone. I'm Josh Dillon, and I'm a lead on the TensorFlow probability team. And today, I'm going to talk to you about probability stuff and how it relates to TensorFlow stuff. So let's find out what that means. Okay, so these days, machine learning often means specifying deep model architectures and then fitting them under some loss. And happily, Keras makes specifying model architecture relatively easy. But what about the loss? Choosing the right loss is tough. Improving one, even a reasonable one, can be even tougher. And once you fit your model, how do you know it's good? Does accuracy tell the full picture? Why not use mean, entropy, mode? Wouldn't it be great if there existed some mathematical framework which unified these ideas? Better still, wouldn't it be nice if it was plug and play with Keras and the rest of TF? This would make comparing models easier by simply maximizing likelihood and having readily available evaluative statistics. We can rapidly prototype different generating assumptions and quickly reject the bad ones. In short, wouldn't it be great if we could do this? Just say, I want to maximize the log likelihood, and then summarize what I learned easily and in a unified way. So let's play with that idea. Here we have a data set, these blue dots, and our task is to predict, our pretend task is to predict the y coordinate from the x coordinate. And the way you might do this is specify some deep model. And of course, you might choose the mean squared error as your loss function. Okay. But our wish here is to think probabilistically. And so that means maximizing the log likelihood, as indicated here with this lambda function, the negative
here, but he couldn't make it, and he was my machine learning Jedi master. And then Pi School of AI and Sebastian Bratiers and Lukas Kaiser for their amazing mentoring. And Marika Shone, who is the high school teacher that actually allowed us to involve those students that worked for the platform. And of course, all of the graduate and undergraduate students that worked with us and helped us achieve what we have achieved and what we plan to achieve in the future. And of course, thank you for your attention.
Thank you, Elena. All right, this is the end of day one. We hope you had a great time. A big thank you to our speakers, our staff, our crew, and to the audience here in Sunnyvale and all around the world. And with that, let's take the live stream out with a look at some highlights. Thank you, Elena. All right, this is the end of day one. We hope you had a great time. A big thank you to our speakers, our staff, our crew, and to the audience here in Sunnyvale and all around the world. And with that, let's take the live stream out with a look at some highlights.